guys. Sorry, I had a dog choking. All right, so today, as promised, Tuesday, April 21st, we are going to start the law of exponents. So we are finished with cube roots as far as like what they mean and estimating them and those kinds of things. We will see them all the time still because we're clearly working in exponents, and that's what it is. So today, the first thing I want to talk about is the anatomy of an exponent. So let's see if I can move this up a little bit here. When we talk about the anatomy, we talk about what things are made of, like our body, the anatomy of our body. We're made of fingers and toes and arms and legs and ears and eyes and those kinds of things. So I thought that was a good word to talk about exponents with. So there's two parts to an exponent. So you'll see a big number. So I'm just going to use that as n because it can mean any number. And this we call the base. Okay, that's going to be important to remember. Then the exponent itself, so say we want, I'm just going to make this x. You can make it a number if that's easier for you to remember. This little number then is the exponent. That tells us how many times we multiply the base. Okay? Now today we're going to be talking about one of the laws of exponents. There's 6. We're going to just start on the first one today and tomorrow. But it's important that you start referring to the larger number or the variable, whatever might be here, as the base, and recognizing this is the exponent, because that's how the language is and that's how it's going to work. So I hope that makes sense. So keep that in mind as we continue on through the laws of exponents. So the one we're going to talk about today is called product of powers. So this is the first one. So it's called product of powers. Well, let's think about that for just a quick second. What does product mean? Product means to multiply, right? So that means our bases are going to be multiplied. So that's what part of that meaning means. So this product means that the same bases are being multiplied. Okay? The important thing to remember here is same basis. This is the important part of this. Remember, the base is the large number or the exponent. They have to be the same. They both have to be 2 or they both have to be x. And I'll do some examples here in just a minute. But the same bases are being multiplied. So I'll show you a problem here and that'll make more sense. So if the same bases are being multiplied, then you add your exponents. Okay, so I'm going to show you what that looks like. So that's what the words mean. I'm going to take this off, set it over here for now. So I could make some examples for you to see. Okay, so the first one, let's try something. So let's try something really easy. Everybody likes the number 2. So let's say 2 to the 3rd power times 2 to the 5th power. Okay? This is my base. This is my base. Base and base are exactly the same. 2 and 2, they're the same number. Okay? So when we go ahead and simplify this, is how we would refer to that. I'm going to keep the same bases too. I'm not going to multiply them. They're going to stay the same. So that's going to stay a 2. Okay? But I am going to add these exponents. Let me do that a different color. So my exponents now are 3 plus 5. Okay? So to complete the simplification, again, my base is 2. That stays the same. I'm not multiplying. Do not multiply 2 times 2. That's not what we're doing here. So my base stays the same. I'm adding my exponents. So it's 2 to the 8th power. Okay? Let's look at that in a different way. Let's look at it with letters. So let's try the letter B. This is multiply here. In this case, the only way this works is if you're multiplying. If any other operation, it doesn't work. We have different rules for different operations, just like we do like the commutative property or the associative property or distributive property. We have different rules for those. So our bases are B, so this is our base, and then let's make this 4 and this one 6. Okay? So when we multiply B, well, that's B and B. So we have B as our base. We're going to add our exponents, 4 plus 6. So when that's completely simplified, it's B to the 10th power. Okay? I'll do one more. We can have more than one variable here, but remember we need to keep the variables that are the same together, just like we do in solving linear equations. So let's look at x to the 7th times x to the 3rd times y times y squared. Okay? Again, let's look at what is the same. So we look at what is the same. Well, my x's are the same. So they're in yellow. And my y's are the same. Those are in orange. Okay? So when I simplify that, I want to add the exponents of the same basis. So x and x. So we're going to have an x here. Their exponents are 7 and 3, so I'm going to add 7 plus 3. Okay? This is still times. We haven't changed the operation. And now I have another variable of y. Well, when we have no exponent here, the assumption is that is 1. This is y to the 1st power. So you'd have 1, whoops, shouldn't have crossed that, plus 2. Okay? So let's finish this. Let's continue to simplify. So we have x, 7 plus 3 is 10. And then times y, 1 plus 2 is 3. Okay? I will make a short video of how to do your assignment today. It's in Google Slides. But hopefully this gives you a good idea of what product of powers is. Remember, it's the same bases are being multiplied, then you add the exponents. So these are your same bases, they're being multiplied, so we keep that base, then add your exponents to continue to simplify, and you get 2 to the 8th power, because 3 plus 5 is 8. Okay, we're only going to do a new rule every other day so we don't get them all mixed up. But if you have your notebooks, I would be writing these down so you can go back and refer to it, or you can watch the videos as many times as you want. All right, have a great Tuesday.